Hey guys, we're back. Let's try a couple examples just so we can solidify that knowledge in those notes that we looked at today. These are different from your homework, but quite similar. Oh, look at that, drawn off screen. I tend to do that a lot. All right, let's take a look. What if I have an angle that's 71 degrees? It's a right triangle, and I am given these two lengths. I'm trying to solve for x. What can I do? Let's label that triangle first. Opposite of 71 degrees is x. My hypotenuse is always that diagonal. And my adjacent side is the side that's next to this angle that I'm given. So what can I use? Let's think about SOHCAHTOA. Conveniently, I'm going to look at sine first, and I can see that sine is equal to my opposite side. Hey, I'm given that, and my hypotenuse, which I also have. So I can take sine of my angle, and I can set that equal to x over 12. Now, how do I get 12 out of the denominator? That's important. I want x by itself. So I can multiply by 12 on both sides. And I'm going to cancel these 12s out, and that leaves me with 12 times sine of 71 degrees equals x. And then, hey, I get to have a calculator moment. I'm just about done solving, just looking for that final answer. And that is about 11.3 equals x. Once again, if you're not getting that, give me a holler. We can help you get that calculator in the right mode. All right, let's try another one. Look at that, that's funny. All right, let's think about if we have a triangle, a little bit different orientation. It's a right triangle, of course. This angle is 15 degrees down here. And I've got my hypotenuse is equal to 10, and my adjacent side is x. So I'm going to label my sides first. This is adjacent. It's next to this 15-degree angle that I'm given. My hypotenuse is that diagonal, and opposite is directly across from the angle I'm given. So let's try to pick what we can use to solve for x. You can catch me writing SOHCAHTOA lots of times. I don't even have it. Well, I mean, I have SOHCAHTOA memorized, but looking at this right away, I still need those references to say, what can I use for sine, cosine, and tangent? I need the mental reminder, so it might be helpful for you guys to write that out. So I got this 15-degree angle. Let's think about it. Could I use sine? So I've got my opposite and I've got my hypotenuse. I don't have any value for this opposite side. So right away, I'm not going to use sine. Let's skip around. Let's look at tangent. Once again, tangent has opposite and adjacent. I don't have any value for this opposite side. And that leaves me with one. Let's double check. Cosine is adjacent. Yep, we're looking for that in our hypotenuse, which we have a value for. So we can do cosine of 15 degrees equals our adjacent side, which is x, over our hypotenuse, which is 10. Now, what do I do to get that 10 out of the denominator? I'm going to treat it as cross multiplying this time so you can see it. So I've got 10 times cosine of 15 degrees equals x. All right, another calculator moment. This one's going to turn out to be about 9.7 equals x. All right, let's go again. Move this paper up. I'm going to draw you another triangle. Let's see. I've got x. I've got 13. Here comes a dog into the office. You know how it is. So let's take a look. We have got an opposite side. I'm going to label that with a big O. And I've got my adjacent side. I've also got my hypotenuse. Remember, my hypotenuse is always the same regardless of what angle I'm looking at. It's that diagonal. So, with what I'm given, let's write it out. SOHCAHTOA. Which one works? Let's think about sine. I have my opposite, so yes. I don't have any value for my hypotenuse. So let's cross that one out. What about cosine? I have my adjacent. Cool. What about my hypotenuse? Once again, I don't have that value. Tangent. Hey, we're only left with one, but we still got to make sure it works. So I have this angle. I've got my opposite, yes, and I've got my adjacent side. Awesome. So let's put it together. So I have tangent of 38 degrees, and I'm setting that equal to what? Well, TOA, opposite over adjacent. So I'm going to have 13 over x. And would you look at that, we have an x in the denominator. Well, it's the same process as we were doing earlier. We're just working with a variable instead of a number this time. So I'm going to multiply both sides by x. These are going to cancel out, and then I'm left with x times tangent of 38 equals 13. So what do I do now? Remember, the tangent of 38, if I want to do this function, that's just a number. We talked about this in our notes. Quick aside, if I have x times 3, so 3x equals 9, what am I going to do to get my x by itself? Well, I'm just going to divide by 3. So 9 divided by 3 is 3, so I get x equals 3. So can't I do a similar thing here if I have x times tangent, which I know is just a number? It's a value. So I'm going to divide both sides by my tangent there. All right, scooting the paper up. Let's finish this one off. These are going to cancel out, and I'm left with x all by itself, which is perfect. And then I have x equals 13 over tangent of 38 degrees. Well, that's pretty cool. I can type that into my calculator. Just don't forget these parentheses. Sometimes I even like to put parentheses around the entire denominator, just out of habit. And I get x equals about 16.6. Alrighty, guys. Hope you have an awesome weekend. Happy to see you this week. Really looking forward to next week. We're going to get in the groove of things. So looking forward to seeing you. Bye-bye.